If each member on a 9-person jury acts independently of each other and makes the correct determination of guilt or innocence, that should be innocence, whatever. I'm misspelling it anyway. With the probability of 0.65, the probability that the majority of the jurors will reach the correct verdict, or find the probability that the majority of the jurors will reach the correct verdict. So we're saying there are 9 people that are making the decision here. Each of them, independent of the other, makes the correct determination with a probability of 0.65. So I'm saying this is binomial, because we have repeated trials and each of the trials are independent. I'm going to count a success as the correct verdict. I don't know if this is guilt or innocence, but we're just saying the correct verdict, because that's the only thing we care about here. So n is 9, p is 0.65, that's the probability of a success. And we're saying what's the probability that the majority of the jurors will reach the correct verdict? Well, there are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 jurors. If we want the majority of the jurors to reach the correct verdict, that means we want 5 or greater. So we want x to be greater than or equal to 5. The complementary event here is going to be this stuff over here, the probability that x is less than or equal to 4. Again, I care about the complementary event here because I want to get the stuff to the left, because that's where my binomial CDF comes in handy. So the binomial, or the probability that x is greater than or equal to 5 is equal to 1 minus the probability that x is less than or equal to 4. And this probability that x is less than or equal to 4, that's the thing I can use the binomial CDF for. 9.65, comma, 4. 1 minus binomial CDF, 9.65, 4, which gives me a probability of 0.8283. So there's a 0.8283 is the probability that the majority of the jurors will reach the correct verdict.